A few months ago, I attempted to create a lineup of enemies for my indie shooter. I spent a month concepting, programming, and creating around 8 enemies, all of which were smart, engaging, and fun to fight. Except they weren't. None of the character, behavior, or intelligence actually shone through in the final designs. So I decided to scrap everything and restart the development of my game's enemies. Welcome to Devlog 7. Let's start off by looking at the problems with the old enemies. The way the old enemies worked was that each enemy would have one script on it that handled everything from the AI, pathfinding, attacks, behavioral stages, etc. This caused 3 major problems. The first problem was the difficulty of creating new enemies. If I wanted to create a brand new enemy, it would basically have to start from scratch. Copying the code from another enemy was actually more difficult because of how intertwined the systems were. Since all of these scripts shared a lot of the same code, it wasted a lot of time and was terrible for optimization. Tweaking enemies was also incredibly difficult. If I wanted to change one behavioral stage on an enemy, it would require an additional 20 minutes of tweaking. For example, changing one laser attack to a missile attack would be an absolute nightmare, despite how minor of a change it actually is. The final problem was that nothing was centralized. After creating many enemies, slight differences began to arise in all of them. Some enemy behavioral stages worked differently from others. Enemies with the same laser attack used them differently, and bugs existed everywhere. For example, if I found a bug in my behavioral stages, it would require me to change that code for every enemy, which is naturally difficult when you plan to create many of them. Now though, I've created a modular enemy system that saves hours every time I make an enemy. So let's take a look. I've got an enemy setup script that is shared between every enemy. This script controls everything from pathfinding, behavioral stages, attacks, etc. Every attack is modular and behavioral stages are easy to set up. This system has the potential to save several hours every time I make a new enemy. So let's take a look. There are a couple things that are synonymous across most enemies. These are behavioral stages, pathfinding, and attacks. Every behavioral stage in every enemy functions the same. Firstly, an analysis is done of the environment. Then, a certain stage is set, and a timer plays to start the next behavioral stage. Increasing or changing the amount of behavioral stages was a hassle in the previous system, sometimes taking hours to create a comprehensive behavioral system. Now, I can make an even more complex system in a matter of seconds. To start, we are presented with an array that allows for a value called distance is greater than. This value determines what behavioral stages should play at a specified distance from the player. For example, if the player is close, use a wave attack, but if the player is far away, use a missile and laser attack. Paired with that is an array that controls which attacks the enemy should use at that distance. You then need to add that attack component to the enemy. You can also choose the length of said behavioral stages. I've also replicated this entire system for retreat behavioral stages. When the enemy's health dips below a specified value, the enemy will enter a retreat state and will use the attacks defined in the retreat behavioral stages. I've already mentioned this, but every attack has been put into a sort of modular system. Based on the attacks that an enemy will use, that script is added to the game object. The script for an attack will handle everything from the references to actually running the attack. Paired very closely to the behavioral stages is the enemy pathfinding. Pathfinding is one of the biggest factors in making an enemy feel smart and complex. Originally, enemy pathfinding was basically one line that would set the destination of the enemy to the player. This meant that the enemy would be completely stationary when the player was out of range. If the player entered its range, then it would travel in a straight line towards the player. Then it would stop at its stopping distance, and that was it. This time around, I completely overhauled the system. There are generally 4 parts to pathfinding. The first is when the player is out of an enemy's range. The second is when the enemy travels towards the player. The third is when the enemy stops chasing the player and holds its ground. And the fourth is a retreat state. For the first stage, I set up 2 different waypoint systems. I didn't want enemies to be completely stationary, so I made it so that they would either travel between pre-placed waypoints or travel based on randomly generated points on their nav mesh. The next stage I had to deal with was how enemies traveled towards the players. Originally, enemies would travel towards the player in a straight line. This meant that the player could just shoot straight and gun enemies down. there wasn't any complexity to the stage. Instead, enemies will now strafe side to side as they move towards the player. I've also made it so that certain enemies will actually stay away from open spaces on maps and travel using the cover of the level to reach the player. The third stage is where most of the variation exists. Ranged enemies will do three things. They will maintain a distance from the player, they will maintain a line of sight, and they will strafe randomly. More aggressive enemies will continue to move towards the player's position, sometimes using a bit of procedural movement. Which brings us to the next stage. The fourth stage is a retreat state. The enemy will switch over to its retreat behavioral stages, and will immediately seek cover from the player. Some enemies will move backwards or forwards depending on their settings. In total, this system allows me to create a completely new enemy in about 5 minutes, ignoring the art and animations for that enemy. This means that you can expect the final game to have many enemies in it. Now, as a reward for dealing with my voice for this long, here's what you can expect polished enemies to look like. This right here is the first semi-completed enemy for my game. I'm also really interested in doing a day in the life of a game developer video, but let me know if that's something you'd like to see. I am a student who balances school, sports, clubs, game development, and YouTube, so feel free to comment if you'd like to see that in a video. The next devlog will be about the creation, polishing, and art behind many more enemies, all of which will be made with the help of this new enemy creation system. So with that said, I'll see you in the next one.